This is video 8.7 function notation. When you use an equation to represent a function, it is often convenient to give the function a name, such as f or g. For instance, the function y equals x plus 2 can be written in function notation as follows. Here's an example. Now let's think back to our amazing function machines from the first video. So we have rocket, and arrow, and they have function machine f. So this function machine has the name f, right? And the function for f is x plus 2. So whenever rocket puts in a value of x, it's going to take that x, add 2, and it's going to dump out y. Okay, so this is our function right here. So the function of inserting the x or using the x will be this. So let's explore this a little bit further. The symbol f of x, which replaces y, is read f of x and represents the value of function f at x. For instance, if f of 3 is the value of f when x equals 3. So in this situation, we're going to put a 3 in for x. It's going to go into the machine, be added to 2, and a 5 is going to come up. So if I were to write this out, it would be f of 3 equals 3 plus 2. So in other words, f of 3 equals 5. This represents x, and this represents y, or what we end up with at the end. Now let's look at another example. Here they've given us two functions, function f and function h. It says find the indicated value. All right, first of all, let's think of these as function machines. So let's start with function f. All right, f of x. All right, so this is our little machine. When I put any value of x in there, I'm going to take and multiply it by 4 and subtract 3. So that's what this function equals. The h function is different. When I put x in, and the x goes into the machine, I'm going to multiply by a -5 and add 7. So let's find the indicated value for each of these. Question 1. Find the f of x when x equals 6. Alright, that means I'm going to use this machine because it's the f function, or it's been labeled that. So now what they're saying is that the function of 6, which is representing x, equals 4 times 6 minus 3. You'll notice I've substituted 6 in place of the x's. So now the function of 6 equals 24 minus 3. F of 6 equals 21. And that would be my answer. I found the indicated value. Now let's look at this one. It's a little more interesting. For this problem, it's saying that I'm going to take the function f and have 3 negative 3 be x. And I'm going to take the function h and I'm going to use 2 for x. And then I'm going to add the answers to those two things together. So basically what I'm doing is I'm taking, let's actually just write it out. For f of negative 3, I'm going to take 4x minus 3, and I'm going to put a negative 3 in place of the x. And I'm going to add that to negative 5x plus 7, and instead of x, I'm going to put a 2 here, because this represents the h function, and this represents the f function. So I used a 2 for h, and a negative 3 for the f function. I'm going to solve these and add them together. So that means I'm going to take 4 times negative 3 minus 3 plus negative 5 times 2 plus 7. This is going to give me negative 12 plus negative 3 plus negative 10 plus 7. If I add all these up together, I'll get negative 18. Negative 18 equals the f of negative 3 plus the h of 2. Now for this problem it says graph the function, right? The function's name is g, right? Otherwise, this is just like saying y equals 9x minus 7. I'm going to solve it the same way. I'm going to make an xy chart. I'm going to make g of 0, so that means I'm going to insert 0 into the function machine, and then it's going to be multiplied by 9 and subtracted from 7, which will give me negative 7. And then let's also try 1. So that's going to be g of 1. And in that equation I'm going to take 9 times 1 minus 7. And that'll give me 9 minus 7, or 2. Alright, so now I have 2 points here that I can graph on my coordinate plane. So my first point is 0, negative 7. That's my y-intercept. Oops. Let's try that again. Okay. And then I need to graph 1, 2. So I'm going to go over 1, up 2, and that's right here. Now I can also look at this as my original equation had a slope of 9, a y-intercept of negative 7. Okay, so if I count, go up 9, 1, 3, 5, 7, 9, and over 1, that's my slope, so it worked. And then I'm going to draw my line. So now I've graphed this function. It's just like you were doing with y equals 9x minus 7, except now you're naming the function as g. Let's look at another example, one more example. It says write a linear function that represents the graph. Alright, I know I have 2 points here. I have 0, 3 is 1 point, and 6, 2 is another point. Right? So if I call my function f, I know that if I put 0 in for x, my answer is going to be 3. And I know if I put 6 in for x, I'm going to get a 2 out of my function machine. I don't know what's happening inside the function machine yet. I have to figure that out. But I know what represents x and what's going to come out of my machine or represents y. So what's nice here is I also have a special point here where x is 0. Well, we know that's the y-intercept. Okay, so my y-intercept is 3. And now I just need to find my slope. Well, I have 2 points here, so I should be able to find my slope. So I'm going to take the difference of my y-coordinates and put it over the difference of my x-coordinates. And this is going to give me 1 over -6. So I have a -1/6 slope, and I have a y-intercept of 3. Now if I use my y equals mx plus b, my slope-intercept form, I should be able to put this in equation form. So y equals -1/6 x plus 3. Now it says to write a linear function, so I'm going to change that y to the function f of x, and I now have my linear equation that represents this graph. Alright, now let's look at an example that doesn't include a graph. Alright, so this is saying that the f function, when I put 0 in for x, I'm going to get 40. When I put 30 in for x into the function machine, a 65 is going to come out. So these represent 2 points. If x is 0, then out comes y, which is 40. If x is 30, it's this point, then 65 is going to come out, which represents y. So again, I have 2 points. And notice one of our points has 0 in the x-coordinate. So that means this is my y-intercept here. So I know my y-intercept equals 40. Now I just need to know my slope to be able to write my equation. Well, again, I'm going to find the difference of my y-coordinates over the difference of my x-coordinates. That's going to give me 25 over 30. They're both negative. Them both being negative, it means my answer is positive. I want to simplify this by dividing the top and bottom by 5. And I end up with a slope of 5/6. So now I know my slope and I know my y-intercept, so I can write my equation. The function of x, or the f of x, equals, I'm going to insert my slope, 5/6 x plus my y-intercept, 40. So it's like y equals mx plus b. This is the end of the video 8.7 on function notation. There are a few problems for you to try.